as a means of background here, I want to say a few things. I was research and teaching at Virginia Tech for 30 years. Household and structural insect pests. So we built and I directed the Urban Pest Control Research Center. Now, the reason that's important now is that I had 22 graduate students, master's and PhD students, and a few postdocs. And our emphasis was on applications. It was on application technology. So I'll mention some names today. And that's who I'm talking about, some of those students. So that's important for me because we dedicated a lot of our work. I had teams in wood protection and wood infesting insects, cockroaches, application technology, termite application. So our emphasis was research in those areas. I left Virginia Tech 30 years and I was at B&G for 20. I was technical director at B&G for 20 years. I left B&G and now working at the Fountainhead Group. If you know me, you know I don't advertise. So that's it. That's who I work for now. So that's there's a few books scattered around. Some of you may have those training manuals. I wrote the nerdy books to the left there. I taught a course in urban entomology that wasn't in text. I wrote one. And this is a kind of a compendium of urban pests. But I was very happy to write books for service technicians. And there's a few in Chinese if you're up for it. Service technician manuals. All right. Where's my wild finger guy? All right. This is the format of what I'm going to talk about today. That application in pest control. So we're going to talk about equipment. We need to talk about residue. We need to talk about how that residue gets transferred to our target pest. And we'll talk about control. So application technology. I want to talk about where it started, how it's going, and where do we go from here. So, as I've said to people in the past, I'm probably going to tell you stuff you didn't want to hear today. So, buckle up. Yeah, go ahead, sorry. All right. The piece of equipment that is most associated with structural pest control is the B&G sprayer. It had its origin. Two undergraduate students at Purdue had a class project. They designed a sprayer. I think what's important to remember is that Bill Brehm, the B of B&G, George Gilmore was the G. Bill Brehm's father owned a pest control business in North Philly on Front Street. And it was called sanitation and disinfection. Gilmore was a bit of a mechanical engineer. So that combination worked for them. Well, it was a class project. Class project in 1946, an undergraduate class project. That's a 46. That's a 47 Chevy Fleetliner there. So I think what's important is this description of the original nozzle, and we're going to come back to that. It says, deliver while walking a spray that will wet the floor or wall to the point of runoff. That's embarrassing. But that's where we were then. That's where we were. And we're going to see where we've come from that. B&G spray started as a garden spray. B&G never made the tanks. Don't make the tanks now, they never made the tanks. It isn't about the tank. It's about the pump mechanism. It's all about the pump. You can get a garden sprayer, but this is Purdue's an ag school. So they put ag nozzles on that sprayer. Ag nozzles are rated at 40 psi. So the mentality was, well, we need to put 40 psi in that tank. So the pump mechanism was designed to deliver 1 pound per push. So you get 40 psi. They didn't need 40 psi, but that was the thinking at the time. So we're still struggling with that. We're still struggling with something we manually pump. The original nozzle was just a garden nozzle, really. It changed a little bit later. this is 46, 47, 49. Bill Brem sold the first 7 tank sprayers to his father. I knew Bill Brem. He's a very nice man. He had fingers like cucumbers. He was huge. But he's a very nice man, and he would laugh and say he wasn't sure his father ever paid him for this spray. But his father had a pest control business, and there were other sprayers in the market. But that model, that sprayer, with that background, metropolitan Philadelphia, it sort of took off. So let's think of where we are now. It's the end of the 40s, okay? Where are we? Well, we came out of the Second World War with a fair number of insecticides. Agriculture mechanized during the Second World War. It totally mechanized. And it mechanized, and it had available to it finally insecticides. So we came out of the 40s. Oh, thank you. Well, you've been replaced once again.
Technology evolved.
But stay close. You can't trust this stuff. Okay, so we came out of the 40s with organophosphates. Oops. See. Okay. It's all about me being dumb. Okay, so we came out of the 40s with organophosphates. We came out of the 40s with organochlorines, chlordane, DDT. Those are major insecticides. They were available to agriculture. They were available to us. The pest control industry was a bit small then. We were pinstreaming. We were pinstreaming with simple sprayers of deodorized kerosene, orthodichlorobenzene. Pest control was a contact sport then, you know. You physically had to hit those rascals. And you know what? Just as an aside, you had to be good at inspection. It's none of this spray and pray crap. It was a contact sport, and you had to know where to spray that stuff. We come from that. But all right, so here we are. We've got organophosphates. We've got organochlorines. You know, it's easy to say that they were inexpensive. They cost. You know, the cost of them is relative to the time. But we had them. We had tank sprayers. All right, so we're coming out of the 40s. We've got chlordane. It's relatively inexpensive. We're using it for termite control. It's now coming into the household for cockroach control. So, in 1951 in Corpus Christi, Texas, wasn't reported, published in 1952. In 1951, we developed insecticide resistance to chlordane in German cockroaches. That was a watershed. That changed everything. We didn't know anything about resistance in German cockroaches. There's nobody working on German cockroaches. Now we had insecticide resistance in a beast that really we were squirting it with kerosene just 10 minutes ago. So this is a thing. Now, this Goodbye Mr. Roach is actually from 1959. But I'm going to get back to this. And what got us into that was rather innocent, really. We had an insecticide that worked, we had a delivery system that worked, and we had customers that were very glad to see dead cockroaches. That's a good combination, but in a way, it got us into problems. Because we just sprayed the brains out of those houses. And we killed cockroaches. Let me tell you something about the German cockroach. It doesn't forget. It doesn't forget. So I'll leap forward. We were doing some work with fipronil, and the neurophysiologist working with us said, Ramsey, why don't you get out to Roanoke Redevelopment and Housing and see how much chlordane resistance is in that population. I said, Jeff, give me a break. They were built in 1954. He said, just good. We went down there was 33-fold resistance to chlordane in those German cockroach populations. They couldn't even spell chlordane. They hadn't seen that stuff ever, or since 1954. German cockroach never forgets. It's in the bank. So we didn't know that then. We've learned. So we'll get back to this a little bit later. So here's where we are. We'll go ahead to 1968. We've got nozzles. We've got nozzles at 50-degree angle and an 80-degree angle, and we're delivering 17 ounces a minute at 35 psi. You can pump your sprayer up to 40 psi if you're a real man. And then it delivers 19 ounces a minute. Really stupid. And then it drops within six seconds down to 35. So it doesn't make it. Just don't do it. So where we were is we've got these two nozzles. We got pin streams. Pin streams are still there because we've got a bunch of geezers who are used to hitting them with orthodichlorobenzene. Now, we've still got malathion. We've still got diazinon. Malathion, you know, if you're young enough, malathion is not so bad. Huh. Well, it used to be really stinky. They cleaned it up. They've got some of those mercaptors out. Diazinon is a bit stinky too. So there was an odor problem. So B&G joined with spraying systems. They own the patent and created a no drip valve. They named it extended valve. It wasn't B&G. So we've had it forever. It's 22 pieces and quite complicated. It's a razor blade thing for a spraying system. So that's sort of where we were in '68. Now, from this point on, we need to change some things. I will show this sort of thing to indicate it's a spray. But from now on, you're not thinking about that. From now on, you're thinking about this. When you squeeze the trigger and something comes out of that nozzle, it looks like that. There's a sheet close to the top of the nozzle, and then it breaks up into droplets. From now on, for the rest of your time, you're going to think of droplets. You're not thinking about spraying, you're thinking about droplets. I'm going to talk to you about droplets. So we're at a 50-degree angle, the coarse fan spray, 50015, 50, first two numbers. That's the spray angle. The fine fan is at 80 degree. You know, I tell you not to use the fine fan. Droplets are too small. But I want to change your thinking right now. Droplets. Not thinking spraying anymore, just droplets. All right, 1976, 77, early 77. B&G introduced the crack and crevice straw, patented in 78. It's very interesting. It ends up on many insecticide labels for household pest control. We took one of those pin streams and made a straw. So soon after that crack and crevice straw came out, lots of people did research on it. Kramer and his group at USDA, they looked at it in the lab and found out that the efficacy was significantly better than the fan. One of my students, Pat Zangoli, looked at it in the field and said, look, it's totally better. Keep that in mind, because the crack and crevice straw has struggled over the years. But it was a major improvement in our application technology. It was a step of this road that we've been on. Now, here's the thing about the crack and crevice straw that is preachable, sometimes not always followable. If you can treat the baseboard in this hallway, and you can spray 3 ounces there. You can also treat that baseboard with a crack and crevice straw at the very top or the bottom, and you can spray 1 ounce. And the efficacy is going to be better with the crack and crevice straw, and you're going to use less material. So we're not making this stuff up. But it has struggled in acceptance, and I'll talk about that right at the very end. Okay. Here's where we are. We got to the 80s now. Nothing has really changed. Nothing has really changed as far as application technology. is concerned, we got the same nozzles. We got the same thing that we had in 1949. Nothing has changed very much. We added a cracking crevice straw. But what has changed are the insecticides. This is the 80s. We first used pyrethroids, cypermethrin, in apartments in 1981, I think. And these insecticides, the organophosphates and the organochlorines, well, you remember, we were using those at 0.5%, 1%, 1.5%. No, that was standard on the label. Pyrethroids, 0.1, 0.2. With the pyrethroids, there was nothing on the other side of that decimal point. There hasn't been anything since. Pyrethroids, 0.1, 0.2. Do you know the concentration of fipronil? When they brought that stuff to my lab, they said, hey, we want you to test this at 0.006. I looked at my lab technician, I said, Bob, can we do that? He said, yeah, not a problem. 0.006, and it's not done. It's not done. In your career, there's going to be another zero added there. So that's where we're going. If you were of this generation, the organophosphates and the carbamates, the organochlorines, when I first used cypermethrin, holy cow, there was cockroaches everywhere. I didn't know what to do. I had 14 apartments to spray that day, and the first one I treated, they were everywhere. I just couldn't believe it. That's what the organophosphates did to cockroach control. They just blew the doors off it. Those cockroaches had never seen the likes of that before. And of course, with use, we have resistance. We still use of the pyrethroids. We still use them. They're still effective. But what they brought to us was efficacy at low concentration. You don't need to spray the brains out of the place. You just need to carefully apply it. All right, here's what we struggled with. We struggled with this concept of more is better. I still struggle with that one. More is better. It just spray it. You know, people talk about clean-out rates. Good grief. There's no data to support clean-out rates. Zero data. So people talk about hose it down, 1 to 2 gallons per unit. We have this mentality of just more is better. It's the need to squeeze. You put a trigger in someone's hand, they're going to squeeze it, and liquid's going to come out. I was there. I did the same thing. You're spraying under a kitchen cabinet? Oh, come on. It's what you do. No, we've got to stop doing that, really. So let's talk about it. We'll talk about it in a few minutes, but here's the other thing we struggled with, and that is application. The tip of the spear here, what's at the end of that extension you've got in your hand, that's the nozzle. David Byron worked with me on fleas in houses, where they are, how to control them. Vacuuming is not the answer. But David was a nozzle guy. And what David did was he contacted pest control operators around the country and he said, hey, give us your nozzle, we'll give you a new one. All we want from you, just tell us how old the thing is. Just give us an idea. Well, but you tell a pest control operator he's getting something for nothing? Holy cow. So we got lots of nozzles. Here's the sad part. The range of ages that they said that these nozzles were when we got them was from 3 months to 36 months. That's fine. David tested them all. But here's the unfortunate thing. We found there was an average of 14% wear in those nozzles. And the wear ranged from 3% to 27%. So I look out here today and I think, yeah, you got tanks. Oh yeah, you got tanks. And I'm telling you right now, you got 14% wear on those tanks. I just know you. Because you're not any different than the rest of the world. That's important. That's important when you do the math. That's an additional 2.4 ounces a minute. That's 2 of those 12-ounce bottles every 1.5 tanks. Think about that. You don't need to do that. That's crazy. It's all for the sake of a worn nozzle. And now you know. It's done. Now you're not going to sleep at night. Because now you know. That nozzle you got is probably 14%. Maybe it's 10. Yeah. Brass wears out. So, okay, you know what? No, you can't look at it. That's not going to happen. But what I can tell you is, you can pump that tank up to 35 psi, 25 strokes by the way, and point it into a 17-ounce water bottle. And if you fill that water bottle in less than a minute, change the nozzle. Done. I can tell you that if you put 358 gallons through that tank, you probably got 70% wear. It's the way the stats work. You know, you can round it up to 360 and get it back to 14%. It's just the way the graph worked. For me to say 358 gallons is 17% wear. But it doesn't matter. If you get 350, 360 gallons out of one tank, one nozzle, bang, done. 17% wear. Just don't do it anymore. It's costing you money, it's wasting insecticide, and it's just crazy. So you don't have an excuse now, that's done. Think about that nozzle. It does not last forever. So Claude did a postdoc with me. So Claude is interested in, well, he looked at foam under concrete slabs, liquid under concrete slabs, all that sort of thing. Claude convinced me we needed to pour concrete slabs. And then he was going to treat under them, and then we were going to pick them up and sample the soil underneath it. Oh, glory be. Let me tell you something about concrete slabs. They can be pretty heavy. Whoa. But Claude looked at, he's interested in termicide application. So yeah, do not think that that termite nozzle doesn't wear. No, that's not true. It's in and out of the soil all the time. No, it's low pressure. I understand that. Things wear. Done. You put liquid under pressure through a small opening, it just wears. I don't care what you make it out of. It's going to wear. So think about this: 10% wear. I forget the range that Claude found. 10% wear. That's an additional 50 gallons for every 500. You just don't do that. And no excuse now. Get yourself a 1 gallon plastic container, stick that nozzle in there, and pull the trigger. It should not take you less than 30 seconds to fill it. It's 2 gallons per minute for that nozzle. So you don't have an excuse now. You can figure out how much wear you've got in those nozzles. You can figure out, your cost per finished gallon. You can fix that. All right. So we endeavored to move people in the direction of not over application. We wanted them to understand that less is better. You don't need to soak the surface. So Jing, one of my students, Jing put this together, and what we wanted to do was to give some graphic for you to understand about over application. So take a look at this. What we're showing here is that 200 times, if you apply 200 times wet, if it's 200 times over that surface, it doesn't change the control. They don't get more dead. They're still going to pick up. They're still going to pick up a lethal dose. They're still going to die applying 200 less than what was initially the wet surface. So, but now you're thinking droplets here. I want you to think of droplets. You're applying droplets. So it's all about not over application. They're going to die. They're not going to be deader. Just come back a little bit, and you're still going to get there. Now, let me try to convince you. All right. So remember, we're applying droplets now. Droplets. So when you apply that droplet to the surface, this is what it looks like. It starts off looking like that, and then it slowly dries. It dries pretty quickly, actually, but it slowly dries. Two scenarios. It can create this ring, this coffee ring effect, where the active ingredient is on the outside of that dry droplet. Or it can fill in. It can be solid. So it can be a solid droplet or that ring. So this is what it looks like with a scanning electron microscope. So the ring is a concentration of that active ingredient. Good. When it's a solid droplet, it's sort of more evenly spread. Either way, there's active ingredient there. That's what you're endeavoring to do. You're endeavoring to put droplets on a surface that are going to dry, and then when they dry, it's going to be kind of a solid thing, or it's going to be that coffee ring effect. Okay? All right. Now this is what Jing really worked on. What we wanted to know was how much insecticide does it take to deliver a lethal dose? How many droplets or how much distance does a cockroach need to walk on a treated surface to pick up a lethal dose? That was one of the several things that Jim did. So this is a scanning electron microscope with the underside of a cockroach foot. There it is up there. There's only three pads that actually touch the surface. The big one in the front, I should have raised it up a little bit. The big one in the front sort of contacts the surface when they climb walls. Otherwise it doesn't. And the one in the back never touches. So our target are these three tarsal pads. When a cockroach contacts one of those droplets, and as it turns out, one of those droplets fairly well neatly fits the surface of one of those tarsal pads. Those tarsal pads are a bit thin. That cockroach needs those tarsal pads to be thin because we need to climb walls, we need to get purchase on the surface. So they're relatively thin. They're not as thick as the rest of that cockroach. So when it contacts that dry droplet, insecticide penetrates the tarsi. Inside the cockroach it goes. Cockroaches don't have arteries and veins. It's just a wash in there. The blood just is in that body. So once it gets inside those legs, bang. And the circulation actually runs to the end of the legs and then comes back. So once it's in there, gotcha. It goes directly to the spinal column of that cockroach. You're dead. So there's not a difficulty in transferring that lethal dose. There's not a difficulty in that lethal dose killing the cockroach. It's done. And walking 22 inches. 22 inches, that cockroach will pick up a lethal dose. So your responsibility is to identify the infested harborage, treat around it, treat in it. All that cockroach has to do is leave that harborage and actually only walk about 12 inches. You can't swim halfway across the lake, you know. You get them into that 12 inches and, well, we got you. So it's going to pick up a lethal dose within 22 inches. You don't need to make it wet. We're just doing droplets. Droplets now. It's just droplets. So you're not over-applicating, you're not wetting that surface. There is no benefit. There's no benefit to that. Well, we wanted to know some other things. And so the question was, well, do those cockroaches, when they walk on a microencapsulated formulation, microcapsules are those little beady things, and we sort of know something about them. We know how thick the walls are, we know how big they are, and Jane figured out the amount